Everyone, today in this session I will be discussing about the experiment that is to determine the specific rotation of a sugar using a polarimeter. The main objective of our experiment is to understand how a plane polarized light is interacting with the optical active substance and to understand the various processes and the techniques involved in the measuring the optical activity of sugar solution using polarimeter. And the third one is to identification of the type of sugar solution that we are using in the experiment. The apparatus required for our experiment are the first one is the polarimeter. Polarimeter which is used to measure the angle of rotation caused by the polarized light while passing through the optically active substance. Here the light source sodium lamp is taken as a light source for eyepiece, sugar solution and the beaker. It has been observed that there are certain solutions or certain naturally occurring chemicals which can rotate the beam of polarized light after passing through the solution. These substances which rotate the plane of polarization are known as the optically active substances. There are two types of optically active substance. One is the optical dextrorotatory, and another one is the levorotatory. The dextrorotatory produce the rotation of plane of polarization in the clockwise direction, while the levorotatory produce the rotation of a plane of polarization in the anticlockwise direction. The example of the dextrorotatory optically active substance is the cane sugar, and that of levorotatory is the fructose. Specific rotation. Specific rotation is the rotation of the plane of polarization of a ray of monochromatic light that passes through a tube 1 decimeter long substance that contains the optically active material. The formula for calculating the specific rotation is shown here, where alpha is the total optical rotation, L is the length of the polarimeter tube in which we will fill the sample, and it is we have to measure it in the decimeter. C is the concentration in gram per 100 ml for a sample at a given temperature and wavelength. So now moving towards on the how the functioning of the polarimeter. Here the polarimeter mainly consists of a light source. Here the ordinary light source, light coming from a light source is represented by a monochromatic ordinary light. Another one is the polarizer, which polarized the light coming from which polarized the light. Here the polarimeter tube that contains our sample, analyzer which will analyze how how the how much the angle of rotation is changing or not. So when a monochromatic light from a source is passing through a polarizer, it will convert light into a plane polarized light in which electromagnetic vector vibrates only in one direction. As you can see here, the electromagnetic vector vibrates in all the different directions, but after passing it through the polarizer, it will vibrate in only one single direction, that is vertical direction. So after passing through as the tube does not consist in any sample or optically active material, so there will be no change in the rotation of the electromagnetic uh, vector, and analyzer will detect it as it is. So there the angle between the plane of polarizing and the analyzing prism are same, or that is zero. There light is completely transmitted through. But when the sample tube is filled with optically active substance as shown in the figure 2b, the plane of polarization of emergent polarized changes. So we have to rotate the analyzer prism to for its plane of polarization so that its plane of polarization coincide with the plane of emergent light, so that we can get the maximum intensity transmitted through this. So we will rotate this analyzer through an angle alpha to obtain a maximum transmitted light. So this is the procedure how we will perform the experiment. So in this experiment, we will prepare a Sauvage solution of known concentration. We can vary the concentration depending on our choices. So but these samples are of unknown identity. We don't know whether this is fructose or glucose. We have to find the value of specific rotation, and then by comparing it to the standard value we can identify our sample, that which is our sample. So let's start perform our experiment in the virtual lab. So this is the link for performing the experiment. You have to go to the chemical science, then click on the circular diagram virtual lab, and among the list of experiment you have to select to, to determine the specific rotation. Okay. To switch on this light source, we click on this red button. The light is switch off. Here is the chamber where we'll put the polarimeter tube that contains our sample. Okay. This is the image of our that we can see through eyepiece. Here, here, mhm, here, this positive and negative. Now, so we will record the optical rotation. Here, two buttons are given. The plus and minus buttons are provided to rotate the dial of the eyepiece in the clockwise direction or in anti-clockwise direction. Or here, increment factors through by which will increase the value of angle. Like I have chosen the increment factor 1. So while I will rotate the eyepiece in the clockwise direction, it will increase the value by 1 degree. When I choose 5, so it will increase the value by 5 degree. As you can see, it is a half shade polarimeter. We have to take the readings when both the regions are completely red. So as we can see that after passing a light electromagnetic vector, after passing it through a polarizer, the electromagnetic vectors vibrate in a single plane. So the maximum intensity is observed at 2 points, one at this and another is this, and these two readings should be at 180 degree apart from each other. So as you can see here, increment is by 10, so the value is increasing by a factor 10. So we will click to this continue button to start our experiment. So click here to try out without logging. Okay, here to perform the experiment, we have to select the samples. From these bottles, we can select any sample from this shells. Let us choose. I have select the sample 1. I have to find the specific rotation of this. After selecting the first one, you have to enter the amount of you have to enter you have to input the amount of sugar solution for which you can determine its value. So let us choose. I have selected 30. Concentration is 30 gram per 100 ml. After that you have to enter the value. As you can see here, I have selected the sample 1. The concentration is 30 gram per 100 ml. So let's make the solution here. The solution is present in this beaker. Here I have two polarimeters tube. One is of 8 centimeter and another is of 10 centimeter. For simplicity, I have taken the 10 centimeter tube and I fill this tube with the solution that I have made. So I will put, so to put this tube in the I have put this tube in the polarimeter. Now I will switch on the lid to take out the readings. So I have, in the complete cycle, as we have discussed earlier, there will be 2 points where the completely bright images, or the when the two regions are completely bright or maximum intensity is observed. So let's see, at one angle the maximum intensity is increasing. As it's really increasing slowly, let us increase the increment factor by 10. The value is still not coming, so I will, you can see this arrow is representing the rotation in your eyepiece in the clockwise direction. Okay, the regions are becoming bright, so I will choose the increment factor 1. Let's increase its value slowly. The two regions are still not equally bright. We have to take the value when the two regions are equally bright. So as you can see, this at 153 degree, 153 angle, the two regions are completely bright. As we increase, the brightness starts decreasing. So one angle is at 153, and as we have discussed earlier, that the maximum intensity is observed at 2 points in a complete cycle, and that should be 180 degree apart. So if one angle is at 153 degree, so the another should be at 330. So let's see whether we get the equal intensity or maximum intensity at 330 degree or not. So I will choose the value to increase the value faster. Okay, just chill. I have exceeded. Okay, these two parts are still not bright. I will select. Okay, as you can see, at angle 330 degree, the two regions are completely brown. So in the clockwise direction, the maximum intensity or the two regions becomes completely bright, one at 153 degree angle and another is a 333 angle. Similarly, in the anti-clockwise direction, while we perform, the value of the angle is minus 200, as we can see here. Okay, I have made the table. In the clockwise direction, the value is 1. The two regions becomes completely bright at 153 degree and 333. Okay? But in a single experiment, it is not possible to tell whether the value of what is the actual value of the total rotation. So, therefore, as the observation only tell us about the orientation of the plane of polarization of emergent light relative to that of incident light. Therefore, the actual rotation or maximum is observed at 153 degree or depending upon the clockwise or anti-clockwise direction. Here these two values are correspond to the clockwise direction and these two values correspond to the anti-clockwise direction. Okay. Corresponding to these values, we calculate the value of specific rotation. But we are not sure which one of the value is the specific rotation, as these are quite different from each other. Therefore, to confirm the actual value of angle of rotation or total optical rotation, the experiment is repeated at different concentration and variable path. So, let us perform experiment at 60 degree. So, you will here click here to save and repeat the experiment. So, it select the sugar number 1 that we have chosen earlier. Now we will change its concentration. Initially it is 30. Now I will select it 60. Similarly, I will select it tube with 10 centimeter length, fill it with and put it in the. After that I will switch on the lamp. From here I will perform. So I will start with increasing a little fast. So let's see where we see the angle. Okay, now I will increase slowly to obtain when these two regions becomes equally bright. So as you can see, at 125 these becomes completely bright, and when we increase, the two regions are not equally bright. There is intensity variation in these two half regions. So at 125 the two regions, so first one value is 125, the another should be 180 apart, so it should be around 300 pi. So let's see whether we get the maximum intensity equal in two equal half region at 305 or not. Okay, let's start increasing from here value. So as you can see, the two portions become completely brightened. These are the values in clockwise direction, 125 and 300 pi. So we have calculated the value of. Similarly, we repeat the experiment at 100 concentration. The value of the concentration should be less than 375, and the corresponding values of the specific rotation we have calculated here. So while seeing these values, we can clearly see the value near to the 90 is repeating among all the three experiments. So we can predict that the value of our specific rotation, which is common among these three concentrations, is around 19 minus 19.3 degree. So we will compare it with the standard table. As we can see, the D fructose is having the value nearest to this. So to verify your result, you will click to save form and carry out the calculation. So from the measurement, week after the comparison, we have found that the value of, let's verify whether our answer is correct or not. Okay, so we have got the correct solution. You can repeat the experiment with another solution by clicking here. Now you can select any other bottle 2 or 4, and you can perform the experiment in the similar way by selecting the concentration or repeating. So these are the results that we have found. The specific rotation of the sugar solution that we have calculated is minus 19.3 degree. Here the minus sign represent that our sample is a dextrorotatory or levorotatory. Minus sign here indicate it's levorotatory. Okay, the percentage error in the standard value is 1.19, and the sugar solution is D fructose after comparing it to the standard table, and these are the precautions that you have to take while performing the experiment. Thank you so much.